So every function has a parent graph. And so a parent graph is just saying if you didn't have any extra numbers in your equation, for example, if my function was just x squared, so I have no other numbers, I have no other x's, it's just the most basic equation I can have. So when you have that, every function has that, has a parent function. You need to know first off, what does your parent function look like? And then from there, you can start transforming it. So for example, one of the things that you can do is you can take your function and you can add or subtract a number inside of the function with the x. So think about it as being paired with the x, so much so that you'll a lot of times even put parentheses around it to keep it with the x. And so, for example, with the x squared here, it would be like x plus 3 squared. And so that would make it shift. And what this does is this is going to shift it 3 units to the right, 3 units to the left, actually. It goes the opposite. This one is really weird, actually, when you're with the x right here. You know, usually when we see a plus, we think going to the right or going up. But in this case, the plus means you're going to go to the left 3. So the way I remember this, whether you're going right, left, up, down, we have our xy axis. So here's our x-axis, here's our y-axis. Our x-axis goes right and left. Okay, so that is going to be the direction that, that the function goes when your number is with the x, like it is right here. So because our number is with the x, it's going to move in the direction of the x-axis. But because it's in here, you know, this one's going to go to the left. A lot of times you think about this like if I was to set this equal to 0 and solve, I would subtract 3, and so then I'm going to the left is one way I've heard people talk about that. So this one moves it right or left. I'll go like that, but it's the opposite of what you would think. You can also put a number at the end of the function outside of it, and so we'll call that plus c. And so if I was to add 2 here, what that means is I'm going to take my original, whatever it was, and now I'm going to move it up 2. And this one actually is going to go in the same way that you would expect it to. It's plus 2. This is outside the function, so really what's happening, if you remember, f of x is really just a y. So what you're really doing is you're adding on 2 to the y. And so you're saying the y-axis, the y that's going up and down, you're going to add 2, so you're going to move it up 2 because y goes up and down. See, if you don't understand what I'm just saying, see, here's your f of x, here's your y value, here's f of x, your y value, and then you add c to it. So you're adding c to the y value. Okay, so technically this is your y value here, and I'm adding 2 to it. The only other thing that you can do here that we're going to look at is you might put a number in front and multiply by it. Okay, so maybe I'll put a 4 here. And so if you think about it, remember how I just got done talking about how this is a y value? Well, you just took your y value multiplied by 4. So if this was a 1, let's say if we plugged in a number and you got a 1 here, well, you're taking 1 times 4. It's now a 4. So it just stretched it up and down, just made it taller because every number gets multiplied by 4. Every y value gets multiplied by 4 and it gets stretched. So let's actually look at this example that I have started here for us. So I'm going to start by showing you, here's your original graph, and x squared, the parent graph, starts at the origin, and then it goes up 1 over 1, right? 1 squared is 1. 2 squared is 4. 2, 3, 4. 3 squared is 9. If I went on the other side, it would reflect. So this is your parent function. This is the original function. Okay, now I'm going to do this one in blue. So what we'll do, and this doesn't matter if it's a parabola or any other one that we've looked at, you're going to take your parent function. Remember you have that center vertex. Okay, we're going to figure out how do I move that, and then from there we'll graph. So this says plus 3 inside with the x. That means I go to the left 3. So 1, 2, 3. And then it says plus 2, so I'm going to go up 2, 1, 2, and now my vertex goes right here. So this is where the vertex is of this parabola. Okay, so I've taken care of this, and I've taken care of this. So now we're looking at the 4. Okay, so if I go back to my parent function, originally it went up 1 from the vertex, went up 1 to the right 1. But because I just multiplied by 4, I need to actually go up 4 to the right 1, right? Because it only went up 1 before, now it needs to go up 4. So I'm going to then go over here, and I'm going to go up 1, 2, 3, 4, and over 1. And then, because it's a parabola, the other one reflects. And then this one went up 4. Now I need to multiply that by 4. So it's going to go up 16. This is going to be a really, really, really skinny parabola. That is like a horrible graph right there. Let me get rid of that. Okay, let's try that again. So we still need a little curve here, but it's going to be really, really skinny. Okay, and there is my change. Also, if you put a negative here, then it's going to take it and it's going to take the exact same thing, but it's going to flip it over. So negative is just going to flip it over. So again, your first thing you want to do is know your parent function. Know what that is. Know how it goes up and over for each one. Know its pattern, its typical behavior. And then from there, figure out your vertex. How does that move using these two? And then graph according to that. Now, if that's not changed, if that's just a 1 or there's no number in front, then you can just graph it like the white one is graphed with the same up and overs that we have here.